Good morning, students. Today we are going to study the first unit of chemistry, that is solid state. In lower classes you have studied the properties of solids, that they have strong force of attraction, there is very less space between the particles of solid, as a result of which they have definite shape and definite volume. They are incompressible, they are rigid. Now in this unit you will be studying about types of solids, packing in solids, and properties of solids. Now our today's topic would be the types of solids. Solids, they are mainly classified into two types based on the particle arrangement, that is, it may be atoms or ions or molecules, whatever constituent particles constitute the solid, build up the solid. What is the manner of arrangement of these particles in 3 dimension? So on the basis of arrangement of constituent particles, solids are classified into two types. Number 1, crystalline solid, and number 2, amorphous solid. Solids like sugar or common salt, they are example of crystalline solids. In these solids, the constituent particles possess a regular orderly arrangement of particles, whereas solids like plastics or gel or glass come under amorphous solids. In these solids, the constituent particles do not show a regular orderly arrangement. So let us understand the definition of crystalline solid and amorphous solid from this diagram. In this slide, the first figure shows the structure of crystalline solid. This is the structure of quartz, wherein the silicate units you can see have a regular orderly arrangement, whereas the second diagram is of glass, which is an example of amorphous solid. You can see the difference. In glass, the silicate units are irregularly arranged. So this is the basic difference between the arrangement of particles in a crystalline solid and in an amorphous solid. Now we'll try to understand what are the characteristics or properties of crystalline solid first. From the definition, we came to know that crystalline solids, they have definite pattern of arrangement of ions or molecules or atoms in 3-dimensional network. And if such an arrangement is found, then it is said to be long-range order. Number 2, crystalline solids have cleavage property. That is, when these solids are cut with a knife or a blade, it results in smaller pieces with smooth surfaces. Number 3, crystalline solids, they have characteristic geometrical forms, so that we will be studying what are the different geometrical forms crystalline solids have. Next, crystalline solids have sharp melting point, that is, they melt at a fixed temperature. And lastly, which is most important, that crystalline solids have anisotropic property. So what do you mean by anisotropy? That we will try to understand seeing this figure of sodium chloride. In this figure you can see a 3D structure of sodium chloride, which is made up of sodium ions and chloride ions, where the arrangement of sodium ions and chloride ions in 3 dimension, it follows a regular pattern. To understand In this figure, the sodium ions are shown by red balls, whereas chloride ions are shown by blue balls. Now, to understand the meaning of anisotropy, you observe this diagram carefully. Along x-axis, this is the x-axis, if you see the arrangement of red and blue balls, that is sodium and chloride ions, they are alternately arranged. In the same manner, on y-axis, the arrangement of sodium and chloride ions is in alternate manner, blue, red, blue. Whereas on z-axis, this is z-axis, with white arrow you can see, the arrangement of particles or ions is different from x and y axis. You can find only chloride ions, that is only blue balls. So as the arrangement of particles in z-axis is different than in x-axis and y-axis, hence a particular physical property in a crystalline solid will have different value in different planes as the particles are different, and this property is said to be anisotropy. So crystalline solids are anisotropic. That is important, and you have to remember this property of crystalline solids. Now, what are the properties of amorphous solids? Let us see. Number one, the constituent particles are not arranged regularly in three-dimensional network. That is, they follow short-range order. Number two, they do not show cleavage property. If you cut any amorphous solid, the small pieces of amorphous solid will not have smooth surfaces. So that is the meaning when we say that amorphous solids do not show cleavage property. Number three, they do not have characteristic geometrical forms. Number four, they do not have sharp melting point. Amorphous solids, they do not melt at fixed melting point. For example, glass is an amorphous solid, and when you start heating at a certain temperature, it will start flowing. It has a tendency to flow, and it flows slowly due to high viscosity. And this is the reason that glass is also called as supercooled liquid or pseudo solid, that is false solid. So this is one of the characteristic property of any amorphous solid, that they do not have sharp melting points. And the last one, they have isotropic property. Just now you understood anisotropy. Now we will try to understand what is the meaning of isotropy. Iso means same or equal. So when we say that amorphous solids are isotropic, it means the physical property like refractive index or optical values, they have different. In amorphous solid, the physical properties like electrical resistance or refractive index, they show same value when measured in different directions of the solid. So that is the meaning of isotropy. So amorphous solids, they are isotropic, that is the value of any physical property measured will be same in all the directions. Now next we'll see classification of crystalline solids. Earlier you have studied classification of solids into crystalline and amorphous. That was based on the arrangement of particles in a solid. Now we will study classification of crystalline solids. So crystalline solids are classified on the basis of binding forces, interparticle forces. into 4 types. Number 1, ionic solid. Number 2, covalent, also called as network solids. Number 3, metallic solids. Number 4, molecular solids. And molecular solid is further divided into hydrogen bonded, polar and non-polar molecules. So as you have studied in chemical bonding last year, that ionic solid like alkali metal halides, these ionic solids are held by strong electrostatic forces, whereas covalent solids, they are held by very strong covalent forces. For example, in diamond or in metal carbides, we find covalent forces. Metallic solids, all metals, they are held by metallic forces, that is the force of attraction between a kernel and free electron. And lastly, the molecular solids, that is, it may be held by hydrogen bonds or dipole-dipole forces or van der Waals forces. Now, based on today's topic about solid state, as we had studied the classification of solids or types of solids, there are 3 questions you need to answer. Number 1, crystalline solids are anisotropic in nature. What does this statement mean? And number 2, why is glass considered as a supercooled liquid? And number 3, mention the type of bonding forces present in the following solids. So if you have understood the topic covered today, I am sure that you will be able to answer these questions. Thank you and have a nice day.